My name is Putu Januartha Prayoga Putra. I'm from uh, Udayana University and I'm mechanical engineering. Today I'm gonna presentation about metallurgy and the presentation is about stainless steel. First, the main reference I use it is metallurgy for the non-metallurgist second edition. This is the contents about the chapter 12 is the stainless steel. What I'm gonna presentation about now. As you can see, this is the list. I'm gonna next. The first time, it's a stainless steel. The stainless, the stainless characteristic such that with their alloy are achieved through the information of an invisible and other chromium-rich oxide furnished from that. When damage has the unusable ability to heal itself and in the process of oxygen in order for an alloy to be classified as a stainless steel, it must satisfy two categories. It must contain a minimum of 10.5% GR with at least 50% FH. It must resist corrosion attack from a normal atmosphere exposure. Stainless steel resists stain, oxidation, and pitting when in moist and contaminated air, seawater, and salt spray, and other chemical hostile environment. Most of them structural applications occur in the chemical and power engineering industry, which account for more than a third of the market for stainless steel products, as you can see in the table 12.1. And series and the next an iconic example of the use of stainless steel in a building construction is the Gateway Arch located in HTA Louis. In the picture 12.1, this is 172 meter tall, 630 feet monument, a construction of commemorated the westward exposure of the United States, was designed in 1947 by structural engineer House Card Bendel and architect Euro Serial. More stainless steel was used in the product accessory panel confident the arc than was used in any other single project in history. Over 700 to 25.75 mg or 800 tons. This claiming monument is the testament to the corrosion resistant properties of their remarkable alloys. Next. 12.1 The history of stainless steel. The history behind the development of stainless steel in the early 20th century is the rich art of metallurgy. Ref 12.3 in 190 10, the British journal The Profession of Iron and Steel, Craftsman and Gardener, published the statement the tendency to rust is a characteristic inherent in the element known as iron and will, in all probability, never be totally overcome. In 1911, German researchers Philip Monselin and W. Horners described the effective relationship between chromium content and corrosion resistance in their alloys, like a picture 12.2. This relationship was also discovered dependently allowed highness, a self-taught metallurgist in the United States, how it's credited with the development of stellar. Is a picture of 12.2, the corrosion rates of iron chromium alloy in entertainment water spray at room temperature. Then next, 12.2 modern alloys. Many new stainless steel compositions have been invented and commercialized over the years since the initial discovery of their alloys are made. One of the reasons for the popularity of stainless steel, in addition to their corrosion-resistant properties, is their facility in processing and application. They can also be fabricated using standard powder metallurgy TM2301 stainless steel alloy encompasses a wide range of alloy contents and microstructure. As a result, their grades have very different requirements and for and response to various thermal treatment, depending on the stainless alloy under consideration, the correct stage of the manufacturing process and the intended application. The selection thermal treatment may consist of a number of their processes. First is stress leveling, second enabling, third is preheating, fourth is ultrasmithing, five is quenching, six is cold treatment, seven is tempering, eight is alternate condition, nine is heat again. Next, 303 SE is a 303 austenitic stainless grade that contains a selenium alloy addition in order to achieve the machinability of the material. The interrelationship between the various groups are illustrated in the figure 12.3. The austenitic 300.5 stainless steel grade, also referred to as 18 to 8 stainless, contains the basic chemical composition from which the vast majority of the other grades may be disparate. As described previously, stainless steel can be produced in raw, cast, and PM form. This is a picture of 12.3, as you can see. Next, 12.3 authentic stainless steel. Austenitic stainless alloy are among the most common grades in the stainless steel. They are classified with the AESA 202 or 300 series designs. The 300 series grade are chromium nickel alloys, and the 200 series represents a set of composition in which manganese and or nitrogen replacement some of the nickel. The properties of the 200 series grade may differ appreciably from those of the 300 series, with higher strength being of the most significant different section. They can be needed to achieve surface hardness. Authentic stainless steel are also generally the most creep resistant of the stainless steel alloys, like a picture 12.4. This is a picture 12.4. Then next, there are many slates of standard AACE tapes and the non-standard authentic stainless steel alloy in the literature, but one for informative approach group there's alloy into lean, heat resistance, and each corrosion resistant category. High temperature authentic stainless steel. Table 12.4 High temperature oxidation resistance. This property can be answered through silicon and rare earth alloy addition. Carbon, nitrogen, niobium, and molybdenum alloy addition can be made for application requirement increased strength at elevated temperature. As you can see, this is table 12.4, notable not blade, high temperature austenitic alloy. You can see and you can edit it, and that's all you can do information. Next. Uncharted corrosion resistant austenitic steel, stainless steel, table 12.5, use chromium, molybdenum, nickel, and nitrogen alloy addition for improvement corrosion resistance. Silicon and copper are added for the uncharted resistance to specify corrosion 5 environments. This group include the low carbon grade 316L, 317L, 904L, and many other properties grade. This is table 12.5, typical composition of corrosion resistant austenitic steel, stainless steel. You can see this is all this. Next, the austenitic stainless grade possesses chemical composition that fall within in the austenitic region of the surface ring below. As the chromium content is increased in the austenitic grade to enhance the oxidation resistance and corrosion resistance of their alloy, nickel, or other oxidation stabilizer. Manages nitrogen carbon its other way. Must also be added in matching almost as incident in the figure 12.5 to maintain the stability of the austenitic microstructure if molybdenum or chromium equivalent is added. Corrosion resistant but not oxidation resistant is a change. This is a picture 12.5 cylinder during stainless steel equation diagram. Next, 12.4 Fakultas stainless steel. Fakultas stainless steel are relatively low carbon iron chromium alloys classified with ASE I400 series designation. They are regeneratively grouped into low 10.5 to 12%, medium 16 to 19%, and high greater than 25%. Chromium contents with some notable exceptions. They are generally not alloy with either nickel or nitrogen. The faculties stainless steel have relatively poor high temperature strain and accessibility limit low temperature and large selection toughness. In general, their concession assistance is substantially lower than the austenitic stainless steel, but higher than most of the martensitic grade. Table 12.6, 12.7, 12.8, and 12.9 with list composition and the selection faultless stainless steel. This is table 12.6 as you can see. And then next, this is table 12.7, this is table 12.8, and this is table 12.9. Can time with this, anyone edit it, and we're gonna next. Picture 12.6 lists the relationship between alloy and the resulting properties and processing characteristics of standard ASI fabric stainless steel. Picture 12.6. This is picture 12.6. As you can see, the relationship the family of the fabric stainless steel. The fabric stainless steel are ferromagnetic at the room temperature and possess generally good ductility and formability. The mechanical properties of the fabric alloy are similar to the austenitic alloy in the terms of strength, but they are generally lack the ductility of the austenitic grade. do not have the high temperature strength of the austenitic steel, like a picture 12.7. This is picture 12.7, and due to the body center cubic PVCC crystal structure, fertility are generally unsuitable for the use in the cryogenic application. Next, 12.5 duplex stainless steel. Duplex stainless alloys consists of the two parts at the room temperature, austenitic and fahrenheit, like a picture 12.8. This is picture 12.8. The duplex stainless steel can generally be regarded as the chromium molybdenum ferritic stainless steel with the surplus nickel used as an austenitic stabilizer to create a balanced Fahrenheit and austenite at room temperature. Next, duplex stainless steel are widely used in the oil and gas, petrochemical, and palm and paper industry, and are commonly used in the aquation, chloride, and containing improvements. They are increasingly used as replacement for the austenitic stainless steel that have suffered from the interconnected HGG of the printing during use. Table 12.10. This is table 12.10. List the duplex stainless steel currently covered by UNSE distinction. As you can see, and we're gonna go next now. There are three basic categories of the duplex stainless steel: low alloys, intermediate alloys, and the high alloys or super duplex grade. They are grouped together according to their printing existence requirement number PRNE, which is included according to PR inch equals presentation of GR plus 3.3 times 7 presentation of MO with 16 equal presentation of N. When term in the introduced with duplex grade is modified from the PRN relationship has been proposed, namely PRNN W equal presentation CR plus 3.3 times presentation MO plus 0.5 times percent W plus 16 times percent N. Low alloy duplex grade typical have Ray and S of more than 22. Intermediate alloy grade from PRNS between 32 and 39. Super duplex grade have S greater than or equal to 40. And then next, 12.6 Metalurgi Stainless Steel. Metalurgi Stainless Steel stainless alloy are Fe, Gr, or G alloys that are ferromagnetic, and unlike the other grade of the stainless steel, they can be hardened through heat treatment in the same manner as non-stainless carbon and low alloy steel. They are somewhat confusingly classified along with the ferritic stainless grade in the AESG 400 series degradation. The typical mechanical properties for the number of the metallic grade are listed in the table 12.12. At the most commonly used in the alloy in the group is 410, which contains approximately 12% Cr and 0.15% C in addition of manganese and silicon. And next, this is table 12.12. Typical stainless and selection metallic stainless steel. Next, the stainless alloy are used in the typical requirement: good tensile strength, creep, and factors property in combination with a moderate corrosion resistance, good wear resistance, and the heat resistance up to approximately 300% degrees Celsius and 1200% Fahrenheit. Fahrenheit. Application for the high carbon level grades type 404 grade, including currently mostly insert surgical and dental instruments, spring, valve, gear, shaft, cam, and bearings. 12.61 Heat treatment of mechanical steel, Metalurgi Stainless Steel. Mechanical stainless steel are typically hardened by oxidizing in the temperature range of 925 to 1065 degrees Celsius or 1700 to 1950 degrees Fahrenheit, followed by a questioning in the air, oil, or positive pressure vacuum in order to minimize their type of problem. Preheating is normally recommended. Preheating part of the should be preheated prior to annealing or hand hardening. Operators include part with heavy or thick section, part with contains several geometric chains, part with both thick and thin section, part with sharp corner and reed entrance angles, heavily ground part, mechanized part with heavily deep cut, cold former or straightened part, previously hardened part that are slated for the heat treatment. The next, annealing temperatures are temperatures used for subcritical, isothermal, and full annealing of the metallic stainless steel, along with the resulting vapor of hardening expected for each of their respective annealing processes are showing in the table 12.13 for the selection number of grades. Table 12.13. This is table 12.14, annealing temperature and produce of raw metallic stainless steel. Next. Antestate for the scale of number of raw metallic stainless alloys are recommended outstanding temperature, aqueous media, and temperature parameter are summarized in the table 12.14. Some level of the flexibility may be outstanding in the selection value for their parameter in order to achieve the desired combination of hardness, toughness, and corrosion resistance during heat treatment. This is table 12.14 hardness and temperating wall, metallic alloy, and specific strength and hardness level. And the next, the temperature in the metallic stainless steel between 425 and 540 degrees Celsius or 800 to 1000 degrees Fahrenheit should generally be avoided due to the possibility of the temper bereavement. This effect is produced by a preparation of the preference to at the former austenite grade boundaries during the tempering. The effect is most pronounced at the 475 degrees Celsius, 800 or 885 degrees Fahrenheit. They can result in the dramatic production in material toughness. The effect is illustrated in the picture 12.9 as the fraction of the period austenite grade size and preference contains. This is picture 12.9. The next, 12.7 preparation of present hardening stainless steel. Rock preparation hardening (PH) steel alloy are designed by the IASA 600 series and alloy by non-standard properties composition. However, the UNS designation of the and the proprietary name are their alloy are often used in the with greater frequency that the AASE design table 12.15 lists the chemical composition of the more common PH stainless steel. Of all of the available stainless grade, they generally often the greatest combination of high stainless coupled with the selection toughness and corrosion resistance. The next, this is table point 12.15 composition of PH stainless steel covered by UNH designers. The next, there are two main types of PH steel, stainless steel, Amish-Teknik, and the Martens-Teknik. Semi-austenitic PH stainless steel are externally austenitic in the solution anode condition. After the fabrication apparatus are complete, they can be transformed to be austenitic to Tirta and certain condition heat treatment that convert the austenite to magnetite. The conditioning treatment for the magnetic alloy consists of heating to high enough temperature to remove carbon from the solid solution, and practically it as chromium carbonate Cr23C6. Metalurgi PH stainless steel are the more popular chemical grade because it's their relatively high hardness in the solution and condition, and metallic grade are used in the form of the bar, rod, wire, and heavy forging. They can also produce in the cold roller, set, and stripping, but they are former typical represent much more producing volumes. Next. 12.8 Cast and stainless steel. In general, the cast and worked stainless steel possess an equivalent resistance to corrosive media, and they are frequently used in the injunction with each other. Important differences do exist, however, between some cast stainless steel and their rough counterpart. One of significant difference is in the microstructure in the cast authentic stainless steel. The typical reason for the improvement resistance are apparently alloy with silicon to improve fluidity for the casting for operation preference and the add benefit from the standpoint of HGG. Sand casting are usually stumble of the sand base to remove molding sand and scale, which may place the surface in the small state in compression. The next. As nickel content increase, the second letter of the design is changed from A to Z. The numeral or numeral following the first two letters increase maximum carbon content. Practice times 100 of the alloy. Finally, if the other alloying element are present, they are indexed by the addition of the one or more letter as the suffix to the definition of CF. 8M reference to the alloy and consider resistant surface. C of the 90CR 9NE type feature 12.10 with a maximum carbon content of 0.08% and content of molybdenum Ms. This is Victor 12.10. The next. Comparison of the H-type heat resistant steel casting present in the table 12.18. This is table 16. Casting are classification heat resistant if they are capable of the certain operation while exposed their continue or intermittently to the operation condition that result in the metal temperature in the excess of 650 degrees Celsius or 1200 degrees Fahrenheit. Table 12.18 summarizes the compensation of standard cast heat resistance grade are three grade fabrication: HK30, HK40, HT30. Specification is ASTME H251 for the elevated temperature and corrosion the surface of the pressure of containing part. The next. 12.9 Powder and Metalurgi Stainless Steel. There are 3 out of the 5 family of stainless steel, namely austenitic, phlenitic, and the mesenitic, are anomaly suitable to phlenitic via a provisional PM processing. The metallic grade are used for wear resistance, while alloy from the phlenitic and the austenitic families represent the bulk of PM stainless steel grade. standard PM stainless steel, destination of this listed in the table 12.9. In the addition of the standard PM stainless steel, a number of non-standard grade, custom and properly alloys are in the widespread throughout the PM industry. And the next. This table 12.9 material design in accordance with the metal powder industry federal MPAF standard 335. Next. And that's all the material I'm gonna use, and thank you so much for watching and have a nice day. Goodbye and see you in the next video. Bye.